third project. Like I mentioned earlier, these are senior design one. This is their first semester. This is a UTDesign project that is inspection systems employing DRS, Tamaris, thermal imager, Pico, Projector.
Good afternoon. My name is Ben Lippett, and these are my teammates, Mark Baker, TJ Hampton, Anthony Hernandez, and Andrew Robinson. And this semester we designed a home inspection system employing the DRS Tamarisk thermal imager and using a Pico projector. Anthony and myself worked on FPGA implementation. TJ worked on the hardware compatibility, and Mark and Andrew used OpenCV to design the functions in the system as well as the menu system. Our design is something that you don't typically see on today's market. We focus on stud finding and thermographer applications for it, but there's technology has a potential for a wider range of applications. The system consists of our thermal imager with a visual camera and a Pico projector, allowing you to display output onto the real world. The projector allows for a large display over the problem area and immediate feedback. And FPGA is utilized to act as a frame grabber to grab the 14-bit data from the IR camera and then process to the computer using OpenCV libraries. Currently, our FPGA transfer is lossy, so we have total media and Minicam, which we're using to transfer analog IR data to the computer and still be able to use our OpenCV functions to process it. Edge detection was attempted for the stud find application, but it was not able to detect, or was trying to detect immediate changes in pixels, and the studs are faint if they're discernible, as you can see in that image right there. So we ended up using machine learning algorithms to get a gradual change in pixels and still be able to detect it. The thermographer function is using a temperature formula that is intended for the 14-bit IR data. So currently, the thermographer function we're using is an estimate using the data that we have received. The menu system displays a choice of functions through the Pico projector, and then a laser pointer is used to hover over a choice. Well, the visual camera captures that and then uses OpenCV libraries to select the user selection. Next semester, we will be trying to implement a better retrieval of the 14-bit data from the IR board, create a portable system using a Beagle board. Right now it's on a laptop computer, and then implement a draft find function for doorways and a more reliable detection of studs and drafts. Can you take any questions? Sir.
So this seems to be a fairly ambitious project. You have elements of augmented reality. You're mixing IR and visual camera images. You have an element of projector and camera system. However, some basic things that you have to do here are already giving you a lot of trouble, like noise in the gradient and stuff like that. So, do you see that you'll be able to overcome that?
The FPGA, yes, because currently we are having trouble getting, there's a lot of data loss and going through the FPGA, but we're constantly working on it and we think we see an outcome in the future for next semester.
Okay. As an alternative, you might need to scale down the ambitions of this project. Even a small part of this would be a significantly, interesting project. You have a lot of interesting elements.
Thank you.
How do you put, most all cameras have different resolutions, different sizes, different optics, and it's all different. You bring them together, you're going to fuse it on one image. So you have to do zoom and sizing the
actually able to do that using OpenCV. It's a library of software. You implement it using C code, or actually, I believe it works in multiple languages. But, and it will do that.
And this IR camera, how, I mean, you're not cooling our jingle or anything, I mean, it's just a room temperature IR camera?
Right, but well, it is calibrated, so that's how we can use the thermographer function. It keeps the intensity of pixels so that you can actually calculate it into a temperature. But it's able to see through sheetrock to the studs. This isn't a very good picture. We have a display set up out on the poster so we can show that off.
Are your customers going to be kind of people in the construction industry or in other areas?
Well,
Who is your customer?
well, DRS tasked us with finding a consumer use for their Tamarisk camera. So we came up with this as a means to utilize it more of less of a military field, more of a consumer environment. So we're thinking contractors or people that are doing home maintenance.
If I can make a comment here, there's a program called This Old House. If you look, there are a number of people that have to go into old historical homes, very, very old, where before they had electric and gas light, you will actually have pipes running inside the walls where they would actually still have the piping. So it is really difficult to kind of work in those homes for construction and for renovation. So being able to have a variety of different types of things running inside the walls for something that's 100 to 200 years old is a real challenge for people in the construction industry. So being able to kind of target, I know you don't want to make the problem more difficult, but it seems as though this side would actually benefit enormously from something like this. Because there's already stud finding